Hello, this is Mr. Collier, and today we're looking at domain and range and composite functions. Alright, so the domain is a set of all x values of a function, and the range is a set of all y values. Okay, this is one way to write a function as well, but we won't see much of that. Alright, let's get started over here, and given the functions f and g, sketch the graph of f plus v, state the domain and range of the new function. Okay, so here we've got f of x and g of x, as you can see in the graph, and f plus g of x, well, we can make an equation for it, but you can also look at the points and just add the y values. Right here we got a value of 0, and here we have a value of 1. 0 plus 1 is 1. So you can make like a dot here for the new function. And over here, like we got a negative 1, and we got a 3. If you add those together, you get a 2. Here you have negative 1 plus 1, so that gives you 0. And you can see what happens with these blue dots here. When you add them together, they just line up. Okay? So we get this function. Alright, so line, the slope is not, well, it's not horizontal or vertical, so the domain is going to be all real numbers, which we write like that. And the range as well, all real numbers. We can get the equation of the blue line just by looking at it, or just adding the two functions together. F plus g of x is, add them together, you get half x. It's just half x, which makes sense when you look at the graph, right? Now, if we add these together, it's, well, we get the function just x plus root 4 minus x squared. But you can look at all the y values and add them together. So 2 plus 2 is going to give you 4. Here you're going to have 1 plus, and this is actually like root 2. So anyway, but it's close to 2 here. So 1 plus like 1.7 is like 3.7. Then you got 0 plus 2 is 2. And then over here you got like a, let's go right here to the endpoint. Negative 2, or 0 plus negative 2 is negative 2. And here, we're going to have, well, negative 1 plus like 1.7 gives you like 0.7. So you're going to get this kind of shape, right? It only goes to here. Okay, so notice G is like the domain is x equals all real numbers. But when you add them together, you got to take the smaller domain. Your domain is the same as f. So the domain is x is between, is that right? Negative 2 and 2. Another way to write that is square brackets. X is between negative 2 and 2. Yeah, so that's it for the domain. Well, it doesn't ask you for the range, but you can also see the range clearly, right? Okay, and in here, we can add them together. Actually, if you take a quadratic and add it to a linear, you just get another quadratic, right? If you add them together, you get negative x squared plus 2x plus 1. Alright, so we can graph it straight from this actually, right? So you can even factor out the negative 1. And yeah, actually you can't really factorize that, but we can perhaps find out where the vertex is by doing x equals negative b over 2a. So negative 2 over 2 times negative 1. So that gives you 1. So the vertex is going to be at 1. The y value of the vertex is going to be negative 1 squared plus 2 times 1 plus 1 gives you 2. So the vertex is at 1 comma 2. It's a downward facing parabola. So I guess you can get some more points just by substituting values. Like if you substitute 0, you get a 1. So it's going to look like this, sort of. Anyway, the domain is x equals real numbers for all parabolas without restrictions. Okay, here, so this function is like not defined when x is less than negative 1, so, or negative 3. So the resultant function, when you add them together, is only going to be defined 3 to 3. Okay, so we can show what the graph looks like by adding these points together. This is 0 plus whatever that is, so it's going to be that, right? So it's about 2.5 on the y value here. Here is like 1.7 plus 1.7 is about 3.4-ish. So I think it kind of looks like this. Okay, and we already have the domain. Okay, this is how you write a composition of a function, where you put a function inside of another function. Do g of x first and then f of x. So let's take a look at the next page here. So we got f of x is defined by, a function can be defined as just a set of points, or an equation, or a graph here. So let's do a few of these. F of g of 1 means you do g of 1 and then you put that into the domain of f, get that result, right? So g of 1 is 2. Okay, so that's g of 1. G of 1 equals 2, so then you do f of 2. So f of 2, you put in the 2 for the f and you get a negative 5. Okay, so they all work kind of similar. Let's look at an interesting one, I suppose. So these are in terms of x over here, so let's do these. This is, we put p into h and then into p again. Alright, so h of p of x, let's do that, h of p of x equals, so p of x is this function x plus 1, we put it into here, we have x plus 1 squared. Then we put that into back into p is x plus 1, so it's just x plus 1 squared plus 1. Okay, h of p of x, so we already have that. So those are kind of backwards. Alright, let's look at this next question here. The function q of x equals f of g of x. Find the function f of x if g of x equals this for each expression. Okay, so root x minus 1 equals f of g of x, and we have g of x, so it's f of x minus 1. So this one's pretty easy. Like if you put x minus 1 into what function gives you this, then this means f of x has to be root x, right? Because if you take x minus 1 and substitute it into root x, you get this one right here. So this one, this one's not so easy. You can't see x minus 1. So you can, one way to do this is to rewrite this as 3 times x minus 1. That gives you a negative 3, so you can stick a plus 3 at the end, right? So now it's the right format to see what the function f of x has to be. F of x equals 3x plus 3. Okay? So that's how you do that one. Next, determine the domain and range of these functions. F of g of x. F and g first, okay. So for f, the domain is, well, there's no restrictions here. Domain is all real numbers. For g, x has to be greater or equal to 2 because it's a square root function. You can't square root a negative number. Okay, so that's the domain for that one. F of g of x. So f of g of x, you take g of x and substitute in. So it's 3 times root x minus 2 squared. And you might think that sort of cancels out. And you get 3x minus 6. But you gotta remember, you're like substituting values of x into g first and then f. So you still, even though it's 3x minus 6, you still have a domain of x greater than or equal to 2. Okay, so it takes this domain right here. And this one is the other way around. F goes into this one, so you got 3x squared minus 2. So there's no problem with f. You can substitute whatever x value you want into f. But here you cannot have a negative value under square root sign. So that means 3x squared minus 2 is greater than or equal to 0. And to solve that, you want to maybe factorize it, or maybe just divide both sides by 3. X squared minus 2/3 greater or equal to 0. So x minus root 2/3, x plus root 2/3 greater or equal to 0. This is a parabola pointing up, and this is negative root 2 over 3, root 2 over 3. So your domain here is x is when it's greater or equal to 0. So this is x is less than or equal to negative root 2 over 3, x greater than or equal to root 2/3. And the range for this value is, well, square root. Square root cannot give you a negative number. It can produce a 0, so the range is y greater or equal to 0. Okay, and the range for this one here is, well, your x value is greater or equal to 2. If you substitute in 2, you get 0, so it's also y greater or equal to 0. Okay, next we've got this one here. Alright, we got f, g, and h. Find the domain of each. Okay, the domains are going to be, well, this is 1 over x, so it's all real numbers except 0. That's how you write it for f. And for, or so that's for, wait, that's for f. G, square root of x, so x greater than or equal to 0. And the last one, this is x, all real numbers. So that's the domain range for f, g, h. Sorry, I meant to have it in a different color. Okay, f of g of h, find that and state the domain of this and that. Okay. Okay, so let's do g of h. X first, you take the h, you stick it in the g. So that's root x squared minus 1. Okay, so remember, there's no problem with the domain of h, but when you look at this one here, you see that again, look, the x squared minus 1 has to be greater or equal to 0. X minus 1, x plus 1 greater or equal to 0. This is an upward facing parabola again. Negative 1, 1, so greater or equal to 0 means that the domain of g of h of x has to be x greater than or equal to 1 union x less than or equal to negative 1. Okay, so next, this one, f of g of h, yes. So we can take this and stick it into f, so this equals 1 over root x squared minus 1. Okay, so now, same as before, you can't square root a negative number, but you also cannot have 0 in the denominator, so it's almost exactly the same domain, but x can't be equal to 1, and x can't be equal to negative 1, so here's the new domain. Okay, and the range of each of these. Okay, so to do that, let's take a look at the range here. So you can hit 0 here, so y at the range is y greater or equal to 0, and for this function here, y is just greater than 0. Okay, determine whether this is a function. Well, it is a function. I guess if you look at the graph, you can tell it's a function. That might be the main way you can tell. I mean, there's no reason it's not a function. Alright, let's take a look at the graph. Let's take a look at this graph. So this one right here, let's take a look at. So we got y equals 1 divided by square root x squared minus 1. Okay, so this matches everything we had with the domain of range. Yeah, so you can see it's clearly is a function. You got some vertical asymptotes at x equal -1 and x equals 1, and the graph looks like this here. Okay, so it is a function as it passes vertical line test, the vertical line test. Anywhere you draw a vertical line, you only hit one point, so it is a function.